All right, teamwork problems. One party can accomplish a task. You filling this in a certain amount of time. Another party can accomplish the same task in a certain amount of time, not necessarily the same amount of time. And they can work together and accomplish this task in a quicker, I'm going to go shorter. We got the idea though. A shorter amount of time. All right. We will be solving for the time it takes one of the parties to complete the task, or we will be solving for how long it takes the blank parties to complete the task. What would that be? Fill in the blank. What are we filling that blank in with? It takes the two parties, yeah. Or the combined parties, or something like that, yes. Okay. Now, our key equation here, the rate that it takes one person to do the job plus the rate, we'll go rate 2, that it takes another person to do the job. If they were combined, we'd have a rate of both. Okay. Now, the rates here is the number of, in this case, number of jobs over time. All right. Now, I'm going to tell you we're only going to be talking about one job each time. Okay? To complete one job. So, if person A takes A amount of time to do something, and person B takes B amount of times, then rate 1 plus rate 2 equals rate C. C is the combined time, or the time for combined effort. I'm just going to say it that way. All right? Let's look at the example we have. Here's my example. It takes Tyler 30 minutes to do the detention cleaning of room 111 when he works alone. It takes Trey 25 minutes to do the same job when he works alone. If, let's say, Tyler and Trey are assigned detention the same day, how long would it take them combined to clean room 111? All right. Tyler's 30 minutes. Can someone help me with the equation with the model we're setting here? Okay, what's next, Emerson? Plus 1 over 25. And what's last here? No. No. That wouldn't equal. What do I not know? What do I want to know? How long both of them, how long would it take? If both of them work together, how long will it take? Do I know that? If I don't know that, what do I need? I need a variable. So what does it equal then? Okay. Whatever you're going to use for your variable there. All right? Now, I'm going to tell you something here, guys. You don't need the least common denominator. On this one, it'd be kind of nice. You can just do a common denominator. 30 times 25 times C is a common denominator. But I'm going to go a little smaller than that. 30 is, well, I'm just going to break it down already. 2 times 3 times 5. 25 is 5 times 5. And then you have your C is C, right? So your least common denominator, you need the 2, you need the 3, you need the 5. Is there anything that 25 needs in the least common denominator? Okay, it needs 2, 3, and I have 2 and 3. I have a 5. Does it need anything else? One more 5. And then we also have this C. All right? 2 times 3 times 5 times 5 times C. So that is 6 times 5 is 30 times 5. That's 150C. That's the least common denominator. We have a rational equation. We have an unknown. We have a variable down in a denominator. It's a rational equation. We've been multiplying through by the least common denominator. Okay? Now the thing I said is if you want to use just common denominator, that works too. So I'm going to multiply the whole thing by 150C times 1 over 30 plus 150C times 1 over 25 equals 150C times 1 over C. Okay? 30 times 5 is 150, right? So that's 5C. 25 times 6 is 150, so that is plus 6C. Is everybody seeing where this is coming from? Here the C's cancel. That equals 150. 5C plus 6C equals 150. 5C plus 6C is 11C. Anybody have a calculator handy? We're going to go 2 decimal places in our rounding today, I think. What's 150 divided by 11?
13.63.
13.63. And then, so, combine Trey and Tyler will take 13.63 minutes to clean this room. All right? Many hands make light work. All right. Any questions on that? All right, number 6. Working together, Jenny and Natalie can mop a warehouse in 5.14 hours. Okay, this is the working together time, right? Had she done it alone, it would have taken Natalie 12 hours. Okay? How long would it take Jenny to do it alone? All right. What's different about this one than the first example we had? Sean? The decimal is different. That's right. Caroline? Right. We got to find one of the individual times instead of the combined time, or the work for the combined work. All right? That's different too. So let's keep that in mind and set this up. Anybody got something in mind here? 1 over A. Who's A? Okay, so you're letting A be... I'm going to write this here just so we know that this is Jenny's time alone, right? Okay. Go ahead. Emerson?
1 over 5.14.
Okay, what's that equal? Okay, so plus 1 over 12. And then what's that equal, Emerson?
1 over 5.14.
Right. Okay. All right. Any questions here? All right, now we got a strange number here as far as LCD and stuff. So what I'm going to do is just say the LCD is 12 times 5.14 times A. I'm not even going to multiply those together right now. I may do that later, but okay? So when I multiply through, I'm going to multiply everything by 12 times 5.14. That's a decimal there. That's a times there. Times A. So 1 over A times 12 times 5.14 times A plus 1 over 12 times 12 times 5 point, I should just put that in parentheses. Times 5.14 times A equals 1 over 5.14 times 12 times 5.14 times A. Okay. We're solving. These A's will cancel. Does anybody have 12 times 5.14 calculated? 61.68, thank you. Plus the 12s cancel here, so that's 5.14A, right? The 5.14s cancel here, so that's equal to 12A. And we just have to solve this. If I'm solving this, this is the first thing I would do. I would subtract 5.14A from both sides. And I have 61.68 equals, that's 6.86? 6.86A. And then divide by 6.86, nearest hundredth, so 2 decimal places. What are we getting for A?
8.19.
Okay, and that is really, because I'll bet it was meant to be, I'm going to round that up to 9. When you're that close to 9, let's just call it 9, okay? So A is about 9 hours. So Jenny takes 9 hours to do this job alone. All right? Any questions there?